friends. Hello friends, in this topic we are going to discuss about relative motion. This presentation is prepared by Mrs. Anand Sawan, Mr. M.A. Patwardhan and Mr. Y.D. Kute. Relative motion. The learning objective of this topic are to understand what is relative motion and application of relative motion concept to solve real life problems. It has been established since long that every motion is relative, as an absolute motion is impossible to conceive. The motion of particle with respect to a fixed reference is called as absolute motion of a particle. But the motion of a particle relative to the set of axes which are moving is called relative motion. Consider two observers A and B having translation motion with reference to a fixed observer O. The position vectors of A and B with respect to O are given by RA and RB. The position of B with respect to A is denoted by RB by A. By using triangle law, RB by A, that is position of B with respect to A plus position of A is equal to position of B. Or it can also be written as position of B with respect to A is equal to position of B minus position of A. If we differentiate that equation further, we can get the velocity of B with respect to A or velocity of A with respect to B, which is as shown, where VAB is the velocity of A with respect to B, VB velocity of B with respect to a fixed reference frame, that is ground, and VA is the velocity of A with respect to a fixed reference frame, again that is a ground. For example, if we consider the white speedboat has a relative velocity of 30 km per hour and the yellow boat has a velocity of 24 km per hour, both with respect to the ground. What is the relative velocity of white boat with respect to the yellow boat? So that is velocity of white boat is 30 and velocity of yellow boat is 25. So when we want to find out velocity of boat A with respect to B, so velocity of yellow boat with respect to the white boat, so that becomes velocity of A minus velocity of B, which gives us answer 5 km per hour. The relative motion analysis. So let's discuss the analysis process. The relative velocity equation can be applied using either a Cartesian coordinate vector analysis or by writing scalar x and y component equation directly. In scalar analysis, establish the fixed xy coordinate directions and draw a kinematic diagram for the body. Then establish the magnitude and direction of the relative velocity vectors v, b by a. Write the equation velocity of b is equal to va plus velocity of b with respect to a, as we have seen earlier. And by using the kinematic diagram underneath each term, represent the vectors graphically by showing their magnitudes and direction. Write the scalar equations from the x and y components of these graphical representations of the vector. Solve for the unknowns. Same, the relative motion analysis is also done by vector analysis. Establish the fixed xy coordinate directions and draw the kinematic diagram of the body, showing the vectors VA, VB, R, B by A and W. If magnitudes are unknown, the sense of direction may be assumed. Express the vectors in Cartesian vector form and substitute into VB equal to VA plus W into RB by A. Evaluate the cross product and evaluate respective I and j components to obtain two scalar equations. If the solution yields a negative answer, the sense of direction of vector is opposite to that of the assumed direction. Let's check out a numerical on relative motion. We will solve this numerical by considering a vector approach. Two ships A and B leave the port at same time. The ship A is traveling northwest at an angle of 45 degrees at a speed of 32 km per hour. and if B is traveling at 40 degrees southwest at a speed of 24 km per hour. So what is the velocity of second ship, that is B, relative to the first? So our equation becomes velocity of B with respect to A is given by equation velocity of B minus velocity of A. We write this equation in vector form. VA is equal to minus 32 cos of I plus 32 sin 45j. And for VB the equation becomes minus 24 cos 40I minus 24 sin 40j. For which, to plot this equation, you have to plot the diagram. VB by A, then substituting these values of VA and VB in the above equation for VB by A, we get the equation in this form. Again, to find out magnitude, if for velocity of B with respect to A, we can take the under root of velocity 4.242 square plus 38.05 square. That gives us a velocity of B with respect to A, that is 39.29 km per hour. Thank you.